and they say we need to do it for each monomial. So, well, let's write out each monomial. The 5x cubed, the 2x squared, and the 45x. Okay, so now I want to break them down into their simplest parts. So this 5x cubed is not really a great example to start with. So I want to break 5 down into its prime numbers. So, well, that's not very exciting for 5 because 5 is prime. 5, and then x cubed, how else can we write x cubed into its simpler parts? X times x times x times 3 x's. So x times x times x. Okay? Now what about 25? What can I multiply to get 25? 5 times 5. So there's 2 5s. 5 times 5. And the x squared? X times x. What about 45x? What can we multiply to get 45? 9 times 5? That seems like a good guess. 9 times 5, okay. 9 times 5, and I just have 1x, so that's not exciting. But that's not down to prime, because how can I break 9 down? What can I break 9 into? 3 and 3. So, really, I'm going to have 3 times 3 times 5 times x. Okay, so first thing I did was I found out how to multiply and get 45. 9 times 5. Then I realized I can break 9 down again into 3 times 3. So I no longer need this step. This is written in its simplest form, or in all prime. Alright, so now it's just a matching game. So, what do each of these terms have?
5.
They all have 5. That's a nice easy one. I see a 5 here, 5 here, and 5 here. Are there anything else?
X.
There's x's. How many? Each of them have 3, or each of them have 2, each of them have 1, each of them have 6. Each of them have 1. So I have 1, 1, and 1. Okay, so that's fine and dandy. So now I found the greatest common factor. What is the greatest common factor of these 3 monomials?
5x.
5x. Okay, now this is where I'm going to claim that this is how I undistribute. So I have 5x times what's left over. So in this first case, what do I have left over?
X squared.
I have x squared. Because I multiplied the same base, add the exponents. What do I have left here?
5x.
5x. So plus 5x. And then this last one, what do I have left? 9. Well, it's one thing to claim that these are the same. It's another thing to show it. So how do I show that they're the same? There's 2 ways. We can solve it. We can distribute, which is the way I'll probably suggest. Another way is you could plug in numbers in both and see if they equal. But let's try distributing this one out. So, when we distribute, where do I start? So I'm going to distribute some with the 5x. Multiply those together, and I think you said it. 5x to the third. Okay, 5x to the third. And then 5x times 5x. 25x squared. Oops, I wrote 5. And then 5x times 9. 45x. Is that the same as this? Okay, so in review of this, we have to find the greatest common factor of each monomial. So we found the greatest common factor of each monomial. In this case, it was what? 5x, the thing each term had. And then we multiplied it times what was left. Okay, well there's one example. Let's try this one. Now, where did I start last time? I wrote them in order. Now how did I know what to write here? I wrote